Hi, my name is Medhat Elmasry. Today we're going to build together a server-side Blazor app that does updates, deletes, inserts, and retrieval of data that's saved in a database. My environment was set up according to this website. So I need you to go to this website and make sure that you've set up your application according to the recommendations here. To start with, let me show you what versions of the various tools I have. So I'm going to go into a command prompt and check out what version of .NET Core I have. So I'm going to enter .NET -- version. So you can see here, I've got the preview version of .NET Core 3.0, and at the moment it's preview 5. Let me close this. And the next thing is we're using Visual Studio 2019. So I have the preview version of Visual Studio 2019, and that's based on the recommendations. So I'm going to open that one up. And we're going to create a new project. So I'm going to click on Create a New Project. And before I start creating a project, let me discuss with you a few things. So we'll park this for the moment and look at what we're trying to build. So this describes the client-side version of Blazor. In the client-side version, Blazor runs in a UI thread in the browser, pretty much like JavaScript does. And you can build an application in Blazor using C#. Now, the server side is different. This is the architecture for server-side Blazor. Essentially, Blazor runs under ASP.NET Core on the server, and SignalR uses WebSockets to update the UI in the browser. SignalR actually updates the DOM in the browser based on any changes that happen. So most of the processing is actually happening at the back end. So this is what we want to do today. But the architecture of our application will look like this. We're going to build a class library, and in that class library, we're going to have one shared class, and that's just the student class. And then we're going to build another project, which is our ASP.NET Core Web API app. And this is the app that talks to a database. And the third project is going to be a server-side Blazor app. This is essentially the focus of what we're trying to do today. So now we can get started and let's try to build this application. So back to Visual Studio 2019. The first project I want to create is a class library. This will be the option I'm going to choose for my first project. Click on this and then next. For the name of the class library, I'm going to call it School Library. And for the name of the solution, I'm going to call that Blazor School. Click on Create. I'm going to delete this file because I don't really need it. I'm going to right click here and delete. Now, there's a package that I need. So I'm going to go into a terminal window at this level. So I'll do that by opening the folder here and typing in CMD. So it'll take me into a command prompt. And here I'm going to execute this command because I need to install a package. So the package I'm installing is system.componentModel.annotations. Now if I go in here, you can see that in our CS_proj file, it has installed system.componentModel.annotations. Let me close this. And now we're just going to add a very simple student class. I'm going to go add class. And for the name of the class, I'm going to call it student. And the code for that class will simply be this, where we are just going to capture the student ID, first name, last name, and school. So let's resolve this. So I'm going to import component model.data annotations, which is essentially the package that we installed. This is it. We don't need to do anything more for this project. So I'm going to close this and add the second project. And the second project is going to be the Web API project. So I'm going to go add new project. And for this project, I'm going to choose the ASP.NET Core Web Application. Let me click on Next here. And for the name of this project, I'm going to call it School API. Click on Create. Now, I'll be using ASP.NET Core for my API, and for the template, I'm going to choose this template here. Let me click on Create. Now, we've got two projects. We've got the School Library project, which is this one here, and then we've got the API project. Now, we have to make a reference from the School API project into the Class Library project. So let's do that, because the API project is going to use the student class. So I'm going to go add reference. Add reference here. And I'm going to just check this option here. Class library, then click on OK. The next thing we want to do is our API application needs to have these packages because we're going to be talking to SQL Server. So I'm going to go one by one and install these packages inside of the API project. So again, I'll go to the folder and type in CMD here so I can drop into a command prompt and install these one by one. So I'm going to take this first one, copy it, and paste it here. Then do the next one. Paste it. And then the last, third one. Now, to check our CS proj file, we're going to right-click on School API and choose Edit Project File. And you can see these are the three packages we installed. And the Newtonsoft package was there from before. So we can close this. Since we're going to be talking to a database, we need to add a connection string. So I'm going to add a connection string to this file here called appsettings.json. Open that up, and I'll go to the very top and paste this code. If you look at this code, I've got a connection string called default connection, and these are the details of that connection string. I want to call the database Blazor DB, and the rest is just a standard connection string for SQL Server. Let me close this and save it. In this exercise, I'm going to use the code-first development approach for creating the database. So in order to use the code-first approach, we need to have a database context file. So I'm going to create a new class here, and I'm going to call it the school DB context. Now the code for that here, and this is the code. Let me resolve these namespaces first. I think that's it. So every DB context class has to inherit from the DB context class. And here I'm defining my collection. I've got a collection of students, and that is really a DB set of student, which is going to be created in the database. This is the constructor. It takes the options and it passes it on to the base class. And this method on model creating is essentially creating some seed data. I'm going to create 4 students here, as you can see. So let's close this file and save it. We need to add some code inside of the startup.cs file so that it can create a connection between the connection string and the DB context. So I'm going to open up startup.cs and I'll go to the configure services method and add this code in here. Let me resolve this. And let's just make this look a little bit prettier. Indent it in. So here I'm adding this DB context, school DB context, which is going to use SQL Server, and it's going to use this connection string. This is pretty straightforward. The next step is a little bit interesting. If you've worked with Entity Framework Core in the world of .NET Core 1.0, 2.1, 2.2, and so on, you would create migrations. And the way you would create migrations would be something like this. I'm going to go into a command prompt here. You would go .NET EF migrations, add, and you'd give it a name. Let's say M1. Okay? If I hit enter here, it doesn't recognize it, because what they did was the utility for applying migrations has actually changed. What you need to do now is to add this global utility in your environment, and this is the way you do it. You'd go .NET tool install globally, and you want to install this .NET EF utility, and the version is 3.0.0. I already installed that, so I don't need to do it, but you need to do it. Once you've installed that, then you can run the migrations. The next thing I want to do is add a migration. So let me run a different command, which is this command here, .NET EF migrations add initial migration. So let me copy this and paste it here. After a while, I get this error, which says unable to create an object of type school DB context for the different patterns supported at design time C, and it recommends me a certain URL. Now I went to that URL, and the recommendation I got was that I have to create a so-called DBEContextFactory class. So things are a little bit different between .NET Core 3.0 and 2.2 in the way that it handles the entity framework utility. This could change because .NET Core 3.0 is in preview, but I needed to add a DBEContextFactory class. Let's get started. The first thing I needed was I needed a helper class. So I created a class called configuration helper. And the main purpose of this class is to give me a method that can read the app settings.json file. So let me add this class, and I'll add some code to it. I'm going to take this, delete it, and paste my code. Now, if you look at this code here, first of all, let's resolve this. This class has a static method called getCurrentSettings, and that static method gets a handle to the app settings.json file. It gets an instance of the configuration object, and it is able to read a value that's passed to this method. So this is a very simple helper class. The next thing I want to do is create a DBEContextFactory class. I'm going to add a new class here, and I'm going to call it the school DBEContextFactory class. There you go, add. Now the code for this is as follows. This is a class that inherits from the iDesignTime DBEContextFactory class. And it's got a method called createDBContext. Take some arguments, and here I'm using that configuration helper class, and I call the method getCurrentSettings, and I pass it the setting in the app settings.json file that I want. The navigation for that is connection strings colon default connection. So if you go back here, connection strings colon default connection, and this is going to return the connection string. With this option builder object, I'm going to pass the connection string and tell it that I'm going to use SQL Server, and this returns a school DBEContext object. So this is what I needed to do. Now, if I try to execute the command that I couldn't execute before, it should work. So before I try that, I want to do a build. So I'm going to come here and do a rebuild just to make sure. Now that I have a rebuild, let's go back in here and execute and call the same command that I had a problem with last time. And keep your fingers crossed, hopefully it will work. And sure enough, it did work. So saying done. To undo this action, use EF migrations remove. Now, if we go into the migrations folder, you'll see a file here by the name of the migration that I added. Let's open it up. This file has two methods. It's got the up method, which creates artifacts in the database, and then there is the down method that rolls back whatever it did in the up method. So if we expand on the up method, this statement here creates the students table, and this statement here inserts data into the students table. And of course, the down method, it drops the student table. So this is good. Let's rebuild again. And the next step is to call database update using the .NET EF utility. So let's do that. I'm going to come back here and run this code. .NET EF database update. Let's hit enter. Okay, so that's done. And it says done right here. At this point, we can rest assured that the database has been created and it's been seeded with our seed data. Let's find out. Let's go under View, and we can choose SQL Server Object Explorer. And let me expand databases here, and there we go. This is our database, Blazor DB. Let me expand Blazor DB and we should see the students table. Let me run view data here to see the data in that table. I do that. Sure enough, this was the dummy data that we added. It's looking good. Now I want to create an API controller. So under controllers, I'm going to add a new class and I'll call it students controller. Students controller. Click on add. Now I've got the code for students controller. And the reason I didn't scaffold it is because I had an error when scaffolding it. And that could be due to the fact that I'm using a preview version of Visual Studio. So I hand coded the controller. Now, if you need the code for this controller, you can go to this GitHub repo and have a look at the code. But I'm going to explain it here. Now, this is a standard controller. It is a class students controller which inherits from controller base, and the route for hitting this endpoint is API / the name of the controller. In our case, it would be API / students, and this annotation says that this is really an API controller. We're going to do dependency injection of the school DB context. So we declare an instance variable underscore context here of type school DB context, and the constructor passes a context object that we assign to the instance variable. This method here is the method that gets all the students. So it just does an entity framework request on students and converts it to a list. This one gets one student by passing the ID, and it goes off and gets the student. This one does a put, which means an update. So to do a put, you need the ID and you need the student object. And here, if everything's okay and it passes all these different checks, it does a save. And if the save returns an error, it will throw an exception. And if the student does not exist, it will return a not found. Down here, this is the post student method, which inserts a student. And over here, this is a delete student method that takes an ID, finds the student, and then deletes the student. And this is a helper method to check whether the student exists or not. So this is it for our students controller. Let me rebuild just to make sure that everything's good. Now let's run the school API class. So I'm going to go debug, run without debugging, or control F5. This calls the default values API controller. So now if I replace the word values with students, I should see the data in my database. And it seems to work. So I added students here, and this is my student data. If I wanted to always default to the students API, I can come under properties, and there's a file here called launch settings. Let me open that one up and change every instance of values to students. And let me save, build, and if I run my application, it should default to my students API. So let's close everything. And if you think we're done, I guess there's one thing that we have forgotten, and that is that we have to enable CORS. It's important to enable CORS so that requests from other domains will be honored. So in order to enable CORS, so I'm back in my startup.cs, and in here I'm going to add this code here. Here I'm going to add a policy, a CORS policy, that basically says I'm going to allow any origin, any method, and any header. Then this method here, which is the configure method, and down here I'm going to add this code which says, okay, I want my app to use the policy that was declared up there. So now let's build again and run just to make sure that we haven't broken anything. And sure enough, it's working. So that's good. We've developed our class library, we've developed our API project. Now, the final and the most exciting project that we want to build is the Serverside Blazor project. So at our solution level here, I'm going to go add new project. And just like I did the last time, I'm going to choose ASP.NET Core Web Application. For the name of the project, I'm going to call it Server Blazor. Click on Create. Now, the template I'm going to be using is this one here, the Serverside Blazor template. Now, let us run this application and see what it does. So if I highlight Server Blazor here and go Control F5, here it is. So this is the home page. If we click on counter and I go click, 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 it will update the counter. And this is fetch data. Now the difference between this one and the client side is not to do with the UI. In fact, the UI looks the same. The difference is the way that these click events and any events are being processed. Any change that's happening here is being processed on the server, and SignalR is actually updating the UI. More on that later on. Let us build our student page here. We want to add a new student option under fetch data, and we want to add the functionality for retrieving student data, inserting data, updating data, and deleting data. There is one package that we need in this project, and that is the Newtonsoft JSON package. I'm going to come to the level of the Server Blazor project and go into a command prompt here. So I chose Explorer and I'm hitting CMD here. So I'm going to execute this command in order to install Newtonsoft JSON. So let me paste this here and run. So I think it added it at this point. And there you go. You can see that our CSproj file has updated. The next thing we want to do, like we did with our Web API project, is to add a reference from Server Blazor, which is the Serverside Blazor, into my class library. So I'm going to go add reference. And over here, I'm going to check school library. Okay. This project is all about the UI. So there is a file in here called imports.razor. And this file, it contains all the using clauses that we need for our views. I'm going to add one more using clause here, and that is so that the school library is also accessible to all the views. So we save this. Let's run the application again. If you look at this fetch data option, when you click on it, it goes and it gets some data from somewhere. So let's close this, and you will see that under data here, there is a weather forecast class and there's a weather forecast service class. If you open this one here, this returns a collection of weather forecast objects. We need to do something similar for our students. So I'm going to add a new class here, and I'm going to call it Student Service. And this class is going to be responsible for retrieving student data, for inserting, for updating, and deleting student data. So I've got the code for that. Here it is for the moment. I'm going to resolve all these namespaces. So let's start from the top. This here is the base URL. Now the base URL, it represents the URL of our API endpoint. And how do we get that? Well, I can go to my API project, go to properties, and then debug, and this is it here. The SSL version of this, 44386. You can also run the API application to get the same information. So let me change this. 86 has to have the port number for the service. This method here makes a GET request to this endpoint. It receives a JSON object, and this method here, deserialize object, deserializes this JSON object into a collection of student objects. This method gets student by ID async, gets one student. So you pass it the ID of the student, it also makes a GET request and deserializes the JSON object to a single student object. This is for inserting. For inserting, you need to pass the student object, instantiate an HTTP client object, call the post async, and pass it the endpoint and a string content object. So I have a helper method down here where you pass it the object and it returns for you a string content object. So all of these are calling this helper method. So I'm passing it a regular object and it returns for me a string content object which is needed by this method. Then you have an update student async method, and that requires the ID and the student object. So it calls the put async method of the HTTP client class, and we use the same method here to convert the object into a string content object. Delete is the simplest of them all. You just pass it an ID and it does a delete async, and the ID is passed through the URL line. This is the service class that does all the heavy lifting for us. If we go into the startup.cas for the server application, you will notice here that we have to add a singleton for the service class. In this case, this is what we got out of the box because it was adding the weather forecast service class as a singleton. We need to do the same for the student service class. So I'm going to copy this, come back here, paste it, and then replace this with student service. We want it to be available as a singleton. The next step now is to cater to the UI. So I'm going to add a new Razor page here. So I'm going to take this fetchdata.razor and I'm going to copy it and paste it so that I can duplicate that file. This is a quick way of doing it. So I'm going to rename this as students. So what I did was I duplicated fetch data razor, and I named the duplicate file as students.razor. Of course, the contents of students.razor, I'm going to delete all of it. I'm going to paste the code for this razor page. The first line indicates what the route is for hitting this razor page, and it's going to be /students. This imports the server blazor.data namespace so that we can have access to our student service. And this is where we're injecting the student service singleton into this page, and the instance of that would be called student service with a small s. Now, let's go back and look at this section of our razor page. This section starts with @functions, and it really contains all our instance variables and all of our methods. This method here on init async essentially is called when the page is loaded. When the page is loaded, we're going to call this load method, which is down here, and this is nothing but a helper method, and this makes an async call to get students async in our student service, which returns students. Let's go back up here. If students is null, it's just going to display loading. If students is not null, and we've actually succeeded in reading the students from our API service, we're going to display the students in a table. The headers for the columns are these, and here we're going to iterate through each item in the students collection, and we're going to display student ID, first name, last name, and school. Let us add a students option to our navigation. That is done by going under shared and opening up this nav menu. So I'm going to open that one up, and let me copy one of these menu items and repurpose them for students. So I'll just call the students, and the text that appears to the user will be also students. I think we can try out our application. So in order to test it out, we have to run the API service first. So I'm going to click on my API project and hit Ctrl F5. And this is necessary because this API service has to run before you start using it. Now that it's running, let's go back here and highlight Server Blazor, okay, and run that. And here we go. We've got our students option. Let's click on it and see what happens. When you click on it, sure enough, this is data coming from our service. Okay, now we know that our application is capable of reading data, but our application will not be complete until we've added functionality for adding data or inserting data, updating data, and deleting data. In order to add data, I'm going to add some local variables to my razor page. So let's go back to my razor page, and I'm going to add these instance variables for every column in my database, which is a student ID, the first name, the last name, and the school. I need to add a form for inserting data. So I'm going to add this HTML form here. If you look at what this does, again, I check that my students array is not null. If it's not null, I'm going to display this insert form. This is an input for first name that is bound to a variable called first name, which is this one down here. This is an input for last name, and this is an input for school. And then we have a button here, which displays the word insert. And when it's clicked, it's going to call an insert method. Now, I don't have that insert method, so let me add it. To add an insert method down here under load, And this is what our insert method does. It creates a new GUID and assigns that to the student ID, which is going to be our primary key. First name is assigned to what the user has entered for first name. Last name is assigned to what the user has entered for last name, and same with school. Once we have instantiated the student object, which I call S here, I'm going to pass that to my service, and the service will take care of inserting it. After that, I'm going to clear the fields and call the load method again. Now, I don't have a method called clear fields, and clear fields just clears the fields to give the user a sense that something is happening. It just sets these values to empty. Let's try this thing again. So I'm going to go back to my application. First of all, I have to build. Let's go build, rebuild solution. Then I'm going to go to my service and just refresh this to make sure it's working, it's running. And then I can go now to my server Blazor app and run that with Control F5. So here it is. I have this form that was created for me, the insert form. So I'm going to add some data. We go A, B, 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 and C, C, C. So click on insert. And wow. And sure enough, it gets added. With a new primary key, that's a good. How about we update and delete this data? So to update and delete the data, I need to do a few things. I'm going to add an instance variable here that represents a student object. And I need to determine whether I am in insert mode or delete and update mode. So I've added an enum here. And the enum is declared as mode, and it can have three values: none, add, or edit and delete. And by default, I'm going to set it to none. I'm adding an add button right above the table, and when that add button is clicked, it will call a method called add. So let me create this add method. And so this is my add method. All the add method does is it clears the fields and it sets the mode to add. Now, I'll make a small change to my form here for adding. So instead of saying just if students is not equals to null, I'm going to say if students is not equals to null and mode equals to add, then we're going to show this form. Otherwise, we're not going to show it. So let's try and see what we've done. So I'm going to close this, refresh this again just to make sure that it works. Then let's rebuild and run the application one more time. And now we'll see that if we click on students, we have an add button. If I click on add, it will show the add form. Now, if I insert something, let me go and say DDDD, EEEE, FFFF. And if I go insert, after it's inserted, this form should disappear. So there's one thing we need to do here. Let's close, and in the insert method, let us set the mode to none after the data has been added so that it disappears. Let's try again. Let me click on add and enter something here. Let us say Bob White, and the school would be, let's say, transportation. And if I click on insert, sure enough, Bob has been added over here and that form disappears. So I think we've nailed down retrieving data and adding data. The next step is to start updating and deleting data. Let me add a form for that. Close this and go back, and just under the form for inserting data, I'm going to add a form for updating and deleting data. I can combine both of them. So if students are not equals to null and the mode is edit and delete, I'm going to save the student ID in a hidden input field. I'm going to display the first name, the last name in the school, and I'll have two buttons, an update button and a delete button. So when the update button is clicked, this method update gets called. And the same is true for the delete button. When it's clicked, the delete method is called. Now I don't have these two methods, so let me add them. This is my update method. The update method instantiates a student object and assigns the value for all the data items in that student object. And then it calls the service method that updates the student object by passing the ID and the student object itself. It clears the fields, loads the table again, and sets the mode to none. The delete method, all it does is it calls the delete student async method in my service and passes it the ID that needs to be deleted. It clears the fields, loads the table again, and sets the mode to none. The next question is, how do we select a row in the table to delete? Well, we can add an event handler to the row and find out where is the actual row. This is the row as far as HTML is concerned. We're going to replace that row element with an event handler here. So when the row is clicked, it's going to call a method called show, and it's going to pass it the ID. So now we need to have a method called show. Let's go back and add a show method down here. Now this show method is going to make a request to our service that gets student by ID, and once it gets that object, it assigns it to these instance variables and sets the mode to edit and delete. We can test our application now. So let's rebuild, and now let's run this application, the server-side application. There we go. Now let's highlight this. When we highlight this, sure enough, it shows up here. So instead of DVD, EEE, and FFF, let's put an actual name. Let's say Fred Myers, and then let's call the school business and update. And there you go. Our row has been updated. Now, how about delete? Let's highlight AAA, BBB, and CCC and go delete. And there it is, it's gone. Now I want to find out more about WebSockets and what's really happening behind the scenes. So I'm using Chrome. So I'm going to hit F12. And I'm going to park this on the right-hand side. And on the Network tab, let me refresh here. There is this thing here for WS for WebSockets. So let's click on WebSockets, and then if you click on this and look at messages, these are the WebSocket messages that are being sent back and forth. So for example, if I go fetch data, you'll see that some WebSocket traffic is happening. Let me go click on students, and let's click on add, and you'll see that whenever I click on something or an event happens, the numbers here, they change. The length of the traffic changes. So let me add something here. Let's say Donna Baker, and the school is nursing, for example, and I click on insert, you see the numbers, they change, and things are happening. So there's WebSocket traffic going back and forth. And this is all handled by SignalR. I've come to the end of my tutorial, and I hope that you found it useful, and I hope to see you in a future tutorial very soon. Goodbye and good luck.